Okay, so now it says assume that z-scores are normally distributed with a mean of 0 and a standard deviation of 1. Okay, so they've just told us that it's a standard normal distribution and that we can use the z-score table directly. Then they gave us a between area because the z-score is shown to be between two values. And both of those values have b, right? One of them is negative b, one of them is positive b. So what we know is that both of these values are the same distance away from the mean. And that's very important when you're trying to figure this out because it makes everything a little easier, or, there's one way of looking at it that could seem easier. Now we already know how to find a between area, but we didn't go over how to go the other way around. And when you already know the between area, how do you figure out what the boundaries are for that region? So here we have our z-score. We know it's z-scores because it says so, and also because the mean is 0 and the standard deviation is 1. And then they've told us that the area between two given values, negative b and positive b, unknown where they are, so I'm just throwing them on there somewhere. I could maybe make them closer together because 0.32 is, about 30, a little more than 30%. So maybe, I don't know, maybe somewhere in here. I'm just ballparking it and thinking maybe these values are close to -1 and +1, like 1 standard deviation from the mean. Actually less than 1 standard deviation from the mean, because the empirical rule says that 68% or 0.68 as a probability would be between -1 and +1. So if I'm thinking clearly here, and now I am, it's going to be even tighter in here. It's going to be like closer like this, probably, negative b and b. And so my z-scores are going to be closer to 0 than -1 and +1. That's what I'm trying to say. But they've given me the area that's between them, the 0.3234 is the area between these two twin boundaries. I call them twins because they have the same numerical value, just different signs. I know it's 0.3234. How am I going to figure out the answer here? Well, what I know is that the whole area under the curve is 1. And if I subtract 0.3234 from 1, I'm going to have the two tail areas. So let me write it like this. This region right here, along with this region here as a total, will be 1 minus 0.3234, right? So that's what each of those would be as a, no, I meant to say all together, these two tail areas, the left tail and the right tail, will be a total of 1 minus 0.3234. However, what I want is just half of that because I want the left area, the left tail only. You'll understand why in a moment. I want the left tail, so I'm going to divide that by 2, divide it in half. So now when I find that left area, I'm going to be able to figure out this value, the negative b, by using norm.inverse. Because if you're not looking for a probability, so when you're well, let me start that differently. When you're looking for a probability, you use norm.dist. And we have this page with the 3 different scenarios for using norm.dist when you're looking for a probability. But if you're not looking for a probability and instead you know the probability or the area and you're looking for the boundary, that's objective 2. And notice that objective 2 says we want to use norm.inverse if you know the area already and you're looking for the boundary. Now, also it says that norm.inverse wants you to feed it a left area. That's why I'm only interested in the area to the left of one of my boundaries, because now using that left area, the left area of 1.03234 divided in half, I can use norm.inverse to find my answer. Okay, so now what is that answer there? What is that area to the left? Let's figure out what it even is. I want to calculate the quantity 1 minus 0.3234 divided as a quantity divided by 2. That is my left tail area. .3383. Okay, now I can use that to figure out this answer right here using norm.inverse with my left area, then with the mean and the standard deviation. That's all I need, right? So my left area is the 0.3383. The mean, since these are z-scores, is 0. The standard deviation is 1. Right? So now I'm expecting to get a z-score that's close to 0, and it's negative, because I can see that in my sketch, because I applied the knowledge I have about the empirical rule, and I can see that it's going to be to the left of the mean, it's going to be negative, and so I have a really good idea of what should happen right now. So I'm going to norm.inverse with 0.3383 and the mean of 0 and the standard deviation of 1. And notice that when you're doing norm.inverse, you don't have to say if it's cumulative or not. That's already understood because you're giving it a left cumulative area to begin with. So it's not a question you have to answer here. So you only have 3 arguments: the left tail probability area, then the mean of whatever your mean is and whatever your standard deviation is. So there you go. I got a z-score of negative 0.42-ish, right? So that's what I was expecting to happen. I feel really good about my answer. And I also know that the positive b is going to be the same, but without the negative. So now I'm ready to answer my question. Now notice that it only asks me for b. It doesn't ask me for negative b and also for positive b. It just asks me for positive b. So I can give it this answer, but also remove the negative because it just wanted the absolute value, the distance from 0. It doesn't want me to put the negative there, okay? Anything else that we need to pay attention to? It says enter an integer decimal number accurate to at least 3 decimal places, right? So that means I could round it to 3 decimal places, or I could round it to more decimal places, and it should mark me correctly. And since it's just saying at least 3, which means 3 or more decimal places, I've copied and pasted it in. I don't really want to round it because I already have at least 3 decimal places. And generally, the more decimal places you put in, the more likely your answer is to be marked correctly. So I'm going to go ahead and submit that without rounding it.